Okay. So now continuing this further, now look at log functions and their graphs.
Yeah.
Correct?
Yeah.
Finding the inverse of y is equal to log x to the base 5. So when you're finding the inverse, you remember the steps to find the inverse?
You swap x and the y, and you bring everything on the left side with the y. So you make it x is equal to.
So y is equal to, you make y the subject.
Oh yeah.
Because you've swapped it already.
Yeah, right, yeah.
So that means if I'm doing this over here, y is equal to, if I'm doing y is equal to, let's say, we have to find the inverse of this. Log x to the base 5.
Yeah.
Okay. So now when you're making the inverse, find the inverse of this. So inverse means you replace x with y with x.
Yeah.
So if I'm replacing, what will I do is, I'll instead of
X is equal to.
correct?
Yeah.
Now make y the subject.
So you would bring log base 5 to the left side by dividing it?
You push, you remember?
Ah, yes.
You're converting the base will become base on the other side and you push this up.
Oh.
Okay?
So you change it to exponential.
So yeah, same thing. So the exponential form is so if your function is your log function x to the base 5, then the inverse of that, as you can see here, is 5 to the base x. So the inverse of log function is exponential. And the inverse of exponential function is log.
Yeah. Right. So the inverse. Oh, so the inverse is the opposite. Oh, okay.
Inverse is not opposite. Inverse is inverse. It will undo the action.
Basically, the inverse of a log function would be exponential, the same function in exponential form.
Oh, yeah.
And if you convert that back, it would be
log.
Okay.
The relationship between exponential and log function. The function y is equal to b raised to x and the function log x to the base b are inverses of each other. This means that the graphs are reflection in line y is equal to x. That's the property of any inverse function. You have to reflect in line y is equal to x.
Yeah.
So here they have given you 8a, graph of y is equal to 2 raised to x. You have to graph this.
Yeah.
Y is equal to x and the inverse of y is equal to 2 raised to x. So what will you do first? Tell me.
So first you would find points.
Find points. Chal. So y is equal to 2 raised to x. So what are the points you can take?
So you can use 0, 1.
Okay, then?
You could do 1. Or should we take
1, 2, correct?
Yeah, 1, 2.
3, 8.
3.
Can you take a negative value also?
-1, -2.
No. -1, 2 raised to -1 is what? Half.
Oh, sorry, half. Yeah. Sorry, what was I doing? Sorry. Yeah, half.
So -1 and half. Correct?
Yeah.
Then 0, 1. Correct?
Yeah.
Then you have 1, 2. Correct?
Yeah.
Then you have 3, 8. This is your y is equal to 2 raised to x.
Yeah.
Now, how do you draw y is equal to x graph? Line y is equal to x.
Linear.
So what is it?
So like
0, 0, 1, 1, 2, 2, correct? 3, 3, 4, 4. Acha, -1, -1, -2, -2.
Yeah.
So this is your line y is equal to x.
So that's the intersect. The inverse has to intersect with this.
Not necessarily. It will be reflected in this. This will act like a mirror. It will reflect it.
Okay.
So that means when I'm drawing the inverse of this, so see which are the points that I had. You remember that the point that I had? -1 half. Correct?
Yeah.
So -1 half will become half -1. You
just
flip the x and y.
Flip it, yeah.
So 1, 0. Correct? 2, 1. 8, 3. So you flip that. So 1 half comma -1. Correct?
Yeah.
Then 1, 0. Then 2, 1. 8, 3. So 8, 3 would go somewhere somewhere here, basically 8 comma 3, very far off this. So basically this will come like this.
I see.
So if this is my function, this is the inverse of that function.
I see.
Okay.
Okay.
What is the equation of this inverse? How do you get the equation of this inverse?
You've changed the so you push it.
So y is equal to 2 raised to x. What is the first step?
2 raised to x. So first
X is equal to 2 raised to y.
Yeah. First
you replace x with y and y with x.
Yeah. Right.
Then you make y the subject.
Y the subject. So you change it to x.
So what will it be?
So it would be log of y.
Log x.
Sorry,
to the base
log
2.
of x.
The base will become base on the other side.
Is equal to y.
Is equal to y.
Sorry, yeah.
So the inverse function is y is equal to log x to the base 2.
Yeah.
So I just wrote left hand side.
Right. Yeah.
State the domain and this of what? Of the inverse.
That's the same thing, right? You just wrote y before. Log 2.
Yeah, the same thing. I mean, generally we write y before.
Yeah.
When we write equations, we write y equal to
usually, yeah.
So if you get something, then you rewrite it.
Okay.
Y. State the domain range in this if for the inverse, I think so. Yeah, so state the domain range of the inverse. Come on, look at the green graphic. What's the domain?
It would be negative with all real numbers, right?
And negative, there's nothing, no? There's no.
But you
domain are the x values. What is the minimum x value and what is the minimum? What is the minimum x value and what is the
in this? But is there no values that could go on the left side?
No, right? No.
Wait, the function was.
Your log function doesn't go on the left hand side. Where?
But usually all exponential functions, it's all real numbers, right? That's what I thought.
That's for the domain, yeah.
For domain,
correct,
yeah.
Correct. So domain of the function becomes the range of the inverse. We're looking at green function. Now tell me the domain and range of this.
Oh, because that becomes a range, and if range is always y is greater than 0.
So in this case here, so what is the domain of the inverse?
Y is greater than 0.
No, domain is x, no?
X is greater than 0. Sorry, x is greater than 0. Range, all real numbers.
Y belongs to set of odd numbers.
Yeah.
Asymptote.
It never reaches.
This is a vertical asymptote.
Yeah.
So vertical asymptote at y is equal to 0. Sorry, at x is equal to 0. At x is equal to 0. Vertical line, no? Vertical x is equal to 0.
How would you know it's x equal to 0?
Because the line is passing through x is equal to 0. The vertical line is passing through x is equal to 0. All vertical line equations are like that.
Yeah.
You know vertical line equations?
Y is equal to 2.
That's a horizontal line. Y is equal to a horizontal line. Vertical line.
2 is equal to y?
No. What are you saying? I don't know. Vertical line. Do you know what a vertical line is?
Yeah, of course.
Standing line.
Yeah.
So if I tell you, suppose if I say 0, 1, 2, 3, 4, minus 1, minus 2, minus 3. What is the equation of this line?
X is equal to minus 3.
What is the equation of this line?
X is equal to 0.
What is the equation of this line?
X is equal to 1. Huh? Sorry, I thought you were. Yeah, okay, yes, I know this. Yes.
So that's what I'm saying. So this is a vertical asymptote.
Okay.
This is your vertical asymptote.
Yeah.
For this graph, I'm looking at the log graph. This one.
Yeah, the inverse one. Yeah.
So what's your problem? I mean, what do you not understand?
I'm not understanding how. I thought asymptote is like a point where it never reaches.
So in this case, this graph never reaches. It won't reach, no?
Okay, I see now.
You may think here, but I have not drawn the full graph.
Yeah. Okay.
The grid is given is only this much.
Okay, I see. And then there's no horizontal asymptote because it's negative all real numbers, right?
No, there's no negative. There's no horizontal. X intercept?
There's 1 at x is equal to x1, right?
1. X intercept 1. So x intercept is 1, 0.
Yeah.
Right? The coordinates of the x. Y intercept?
for the inverse. There's no y-intercept to the inverse, but for the original there is. It's 0.
Arey Papa, we are doing the inverse function.
Okay.
Why are you getting so confused?
Sorry.
No vertical, no y-intercept. Why are you getting so confused? Don't get confused, please. We are looking at the green graph.
Okay,
this is all domain and range of the green graph, which is the inverse, which is y is equal to log x to the base 2. You are looking at both and you are getting confused. You are looking both and you are getting confused.
Yeah. Okay. No y-intercept. Got it. Yeah.
The properties, because the chapter is log and its properties, so we are doing the log function. Why are you doing an exponential function?
Yeah.
The properties above apply to all untransformed functions of the form y is equal to log x to the base b. To graph this one, correct? You can use the transformation.
Yeah.
If you use a table, then you choose a value of x, so that x minus h is the power of b. Now this is important. Your x minus h, which is there, x minus h should be power of b.
Okay.
So we'll see that as we do it.
Okay.
So start with the first one. Chalo.
Include at least 3 clear points. So there's no need to inverse this one.
Why should you inverse when you say any graph? Unless they ask you the question.
Yeah, okay.
If they are only if the question asks you, why should you inverse it?
I don't even know.
Graph it, take any 2 points.
But how can you, let's say I plug in 0.
Log of 0 is not defined.
Okay, so if I plug in 1, it would be 0.
So if you like that. So x is 1, yeah, y is equal to log 1 to any basis 0. Yeah, correct. So that's my first point. Correct. Tell me the next point.
Log of 3.
No, tell me the x value.
X is equal to 3.
X is equal to 3. So what will the y be?
It would be
log 3 to the base 3, which is 1.
1.
So 3 comma 1.
Yeah.
Then tell me the next one. X is equal to what will you do? You should take the powers of 3 because 3 is the base.
Yeah.
So whatever the base is, take powers of that. 9?
9, yeah.
Correct?
Yeah, and then make it 3 squared.
3 squared, so 2 log 3 to the base 3, so which is what?
Which is 1. 1 times 2.
Correct. So what's that point?
4, 9 comma 2.
Take a negative value. I mean take on the bottom. Suppose you take x is equal to 3 raised to minus 1. 1 over 3, 1/3.
Yeah, 1/3, yeah.
So what will your y be?
Y is equal to
3 raised to minus 1/3, correct?
Yeah.
So minus 1.
Minus 1, yeah.
So 1/3 comma minus 1.
Yeah.
So substitute now. So 1 0. Correct?
Yeah.
3 1. 9 2. 7 8 9 9 2. Correct?
Yeah.
1/3 comma minus 1. 1/3 comma minus 1. And so on. So this graph will go like.
Okay.
So what's the vertical asymptote?
Vertical asymptote. Never reach x is equal to 0.
X is equal to 0 is the vertical asymptote.
And there's no horizontal.
It doesn't have any, so there's no question of thinking of what's there and what's not there. You say what is there. Don't say what is not there.
Okay.
Chalo. On the same axis, draw this graph.
Okay.
How will you draw this?
So it's the same function, but it's been transformed, right?
Correct. So what are the transformations that you'll apply to this one?
Would it be 2 to the left and 4 up?
Very good. 2 left, 4 up.
Yeah.
So 2 left for the vertical asymptote as well.
Yeah.
So 2 left for the vertical asymptote. And each point will be 2 left.
And
so
4
1,
up.
2, 2 left and 4 up.
Yeah.
1, 2, 3, 4, 4 up. Each point. So 2 left, 4 up.
Yeah.
1, 2, 3, 4. Correct? Then this one 2 left. Correct? 4 up. 1, 2, 3, 4. Correct? This point also 2 left. 4 up. 1, 2, 3, 4. So that means this is what your graph will be.
Is there a way to find these points
Yeah.
without the
Correct.
original function?
Yes. So you take your x plus 2.
Hmm.
You take x plus 2 as the powers of 3.
The powers of, okay. What do you mean? What do you mean by that?
X plus 2 is 3 raised to minus 1. X plus 2 will be 3 raised to 0. X plus 2 will be 3 raised to 1. X plus 2 will be 3 square.
So you do it like, okay.
Correct?
Yeah.
So what will happen is, and then you get the point.
Yeah.
You will get your x, put that x in the equation, get your y.
Okay.
But you have to, it's easier to always take, that's what they're saying. X minus 8 should be power of b. So you take x plus 2 as a power of 3.
X plus 2 is the powers of 3, yeah. Because the base is 3.
Because the base is 3.
Yeah.
Correct?
Yeah.
So basically this will become your x values, minus 1, 0,
and
1,
they do
0.
that so it can cancel, right?
Cancel. You cancel. Now how do you do this? Draw a graph of this. Come on. So what are the one probably will have fraction value of x. So what are the values? So you'll take x minus 1 as powers of 4.
Yeah.
X minus 1, take, I'm writing for hint, as powers of 4. Means x minus 1 is 4 is to what will you take? Minus 1. So you solve it.
So x minus 1
is equal to 1 over 4. So x is equal to what?
1 plus 1 over 4.
5 over 4.
5 over 4.
Now y is equal to what? 3 log. Your x minus 1 is 4 is to minus 1. Correct?
Yeah.
So this will be minus 3.
Mm-hmm.
Correct? No, minus 3.
Wait. 4 raised to minus 1. 5 over 4 minus 1. You plugged in x back into the equation, right?
What is the x minus 1?
Equal to 4.
No, it's not 4. It's 4 is to minus 1.
4 raised to minus 1, yeah.
So I'm replacing the x minus 1 as 4 is to minus 1.
Oh, okay. Okay. But I thought we found x. X is
Put x, chalo na. Put x over here. Same thing will happen.
5 over 4 minus 1
is 1 over 4.
Oh, okay.
1 over 4 is because you are coming from here.
Yeah.
So why do you put this back and then get that?
Hmm.
You can if you want to, if you have time in the paper, you can do that.
Okay.
I mean, that won't make a difference. But it's just this first one.
Okay.
Now, next point.
4 minus
X minus 1.
Sorry, x minus 1
is
equal to 4
raised to 0.
0, yeah.
Why is it hesitant?
It's
powers of 4.
Yeah, you always do 0, 1, and then
minus 1 take a negative value. So solve. What is x?
X is equal to 4 to the power of 0 plus 1, which is 1 plus 1.
It's 1 plus 1.
You bring the 1.
What is 1 plus 1?
2.
So say that.
Sorry.
So y is equal to what?
Y is equal to
3 log 4. What are you putting?
4 to the power of 0.
Yeah, which is what? 1.
1.
Correct? What is log 1?
Log 1 is 0.
3 into 0, 0. So that's your second point. 2 comma 0.
2 comma 0.
There's no space also. That's another problem here. Next. What will you now take? 3.31.
Would 1 be good? 4 to the 1. X minus 1 is equal to 4 to the power 1.
Okay. Or let's take 4 to the power 2.
Okay.
So you'll get a spaced out point.
Yeah.
So what will x be?
X will be equal to 16 plus 1 to 17.
Oh, God. That is a bad idea. Take 1.
Okay.
5.
5, yeah.
Now what is your y?
Y is equal to 3 log base 4. 4 to the power 1 minus 1.
Yeah.
4. Yeah. So base. So equal to 1. 1 times 3. So 3.
So what's your answer?
5, comma 3.
Substitute them.
Yeah.
So 1/4 comma minus 3. Correct? 2 comma 0. 5 comma 3.
Yeah.
There's a problem. X is equal to 1 should be a vertical asymptote. 5/4, no? X is 5/4. This is wrong I did it. 5/4 is here. 5/4 and minus 3. Correct?
Yeah.
Because your x is equal to 1 is your vertical asymptote. See, to find a vertical asymptote, what you do is, to find a vertical asymptote, whatever this is, make it equal to 0. So your vertical asymptote will be x minus 1 is equal to 0, x is equal to 1.
Yeah.
So x is equal to 1 is your vertical asymptote.
You just know that.
Yeah. You just know that, yeah. And then these are the points that you have. And this is how your graph will look.
Nice.
Okay?
Okay.
Easy?
Kind of. But I get it better. I was just getting confused because I didn't think you could it looks difficult, to find numbers with the log function thing.
No, but I told you, you take x minus 1 as the power of 4.
Yeah.
Your x minus h, that's what we generally said.
Yeah.
Your x minus h, whatever the base is, you take powers of the base basically.
Yeah. I see.
Chalo, then
state the domain and range of the equation. So a vertical asymptote that x is equal to 1. A domain is negative all real numbers.
So
sorry, domain is is 1 comma infinity.
yes, 1 comma, but 1 excluded.
Yeah.
Domain.
Range would be all real numbers.
Equation of any asymptote. What is the equation of the vertical asymptote?
X is equal to 1.
Okay.
Okay.
Sure. Find the equation of the inverse function.
Okay, so x is equal to 4y plus 3. And then I do log okay, wait, so
you say the base afterwards. Log x to the base 4.
Log x to the base 4. Yeah.
No.
Y plus 3.
Minus 3 is equal to y, correct?
Yeah.
Therefore, what is my y?
Y is equal to log 4 minus 3. Okay, yeah.
Correct? It's not raised to y.
Yeah.
This one, write this down. Let's see. What you do is replace x with y with x. Correct? Now to make y the separate.
Yeah.
So first I'll take 5 on this side. Correct? Convert this into
exponential.
Correct? Then you take this one this side. So therefore, what's my inverse function? y is equal to 6 x raised to 5 minus 2.
Wait.
So suppose we get a sum like this.
Yeah.
You find the inverse. So basically fx is y. First step is what will you do? Replace x with y. Replace x with y and y with x.
Yeah.
Now to make y the subject means you have to try to isolate the y.
Yeah.
So first you take 5 on this side. Correct?
Yeah.
So then this will become what?
Log 3 x minus 5.
Correct? Now you take this 1 on this side. Correct? Therefore y will be what?
Log. So I did it right, but the only mistake I made is I did bring the 5.
Yeah, you have to isolate
have
the
to
term with the y.
isolate the term, yeah. So it would be x is equal to, and then I bring that 2
Correct.
here, and then I
So you're
log
following
it.
that? So these sort of sums are important where you convert it
Yeah.
log form to index form to log form to find the inverse.
Yeah.
So they can come in any form.
Yeah.
So if it's index form, the inverse would be log form.
Yeah.
And if it's log form, the index would be exponential form.
Yeah.
Okay. Now, the Richter scale is used to measure the magnitude of earthquakes. If an earthquake has the intensity I, then its magnitude of Richter scale is formed by this function. They've given you the formula. Ri is equal to log I upon I naught, where I naught is the intensity of the Berry felt earthquake. So you're comparing that with the Berry felt earthquake.
Yeah.
You're taking a ratio and you're taking the log of that. That's the whole idea. If the intensity of one earthquake is 50 times the other, okay, how many points greater is the bigger earthquake on the Richter scale? If the two intensities are I and 50I, hint they've given you, then try to find the quantity, the difference they want. R of 50I minus R of I.
Yeah.
So do that. Let's start. So basically they're saying that if one how many points greater, you want the points greater. Means the difference of in this we want.
Yeah.
So what do you do is R50I. First you find R50I.
Yeah.
What will that 50I be? Log 50I. Correct? Upon I naught.
Yeah.
Then you find out R of I, which is given to you. What is R of I? Log I
upon I is naught.
Therefore, R50I minus Ri is equal to what?
Or
log 50I upon I naught minus log
I upon I naught.
Combine this into single log. So log
40.
50 upon I naught. Huh? What 40? Log m minus log n. What's the rule of log?
Divide, right? Yeah.
Then divided means we multiply by the reciprocal. Correct?
Yeah.
So this and this cancels. This and this cancels. So what is that?
Log
50. Because this will cancel log 50. Now when there's no base, what's the base?
10.
So that's your Richter scale. That's a difference basically.
Okay.